Okay, here we have a car which is moving with a variable acceleration. So it's moving so that acceleration depends on time. So we can't use the constant acceleration formulae, we have to use calculus. And here we need to remember that if we have displacement or distance travelled, if we differentiate that, which gives us ds by dt, then that's equal to the velocity. And if we differentiate again to get dv by dt, so differentiating, then that gives us the acceleration. And if we want to go backwards, then we have to integrate. So from acceleration to velocity, we integrate. To get from velocity to displacement, we integrate. So we are told that the acceleration is given by this expression, and we're asked to find the velocity. So we are going to need to integrate. So the acceleration is 4 minus 0.2t. Integrating, so we need to integrate this. If we integrate 4 with respect to t, we get 4t. Now if I integrate this, the power goes up, remember, when we integrate, and we divide by that 2, so it's 0.2 over 2. And don't forget that when we integrate, you have to introduce the constant of integration. So if I just simplify that, that's the same as writing that v is equal to 4t minus 0.1t squared plus c. And we need to find out what c is, otherwise there are just too many unknowns. Now we're told that the car accelerates from rest, which means that when t is equal to 0, the velocity is actually 0. So I can put t equals 0, v equals 0 into this. So 0 equals, well, that's going to be 0, that's going to be 0, and there we're going to have c. So c has to be 0. So the velocity is simply 4t minus 0.1t squared. We are asked to find the velocity after 5 seconds, so that's when t is equal to 5. So when t is equal to 5, v is going to be 4 times 5, take away 0.1 times 5 squared, well that's 25, so it's going to be 20, take away 2.5, which is 17.5 meters per second. Right, I wasn't sure what this second bit meant. It said, what's happening to the velocity when t is equal to 20? So first of all, I put t equals 20 into my expression for velocity. So when t is 20, v is going to be 4 lots of 20 minus 0.1 and times 20 squared. Well, that's 400. Well, that comes out as 80 minus 40, which is 40. So you could say that when t is 20, the velocity is 40. I thought I'd look at the acceleration, though. Well, the acceleration we know is 4 minus 0.2 times 20. Well, that's going to be 4 take away 4, which is 0. Now, the acceleration, so if the acceleration is 0, what that actually means is, if you're thinking about a velocity time graph, so this is time and this is velocity, the acceleration is the gradient. So thinking about it, what's going to be happening is the velocity becomes 40 and then goes down again. So at this point here, the gradient or the acceleration becomes 0. So what's happening when t is equal to 20 is that the object has reached its maximum velocity. Okay, last bit says, find the distance travelled in the first 20 seconds. Now, distance travelled is integrating again. We know velocity, we're going to have to go back again to find the distance travelled. So here's my expression for velocity. So v is 4t minus 0.1t squared. So v is equal to 4t minus 0.1t squared. And if I now want to work out the displacement, what does it say? Distance travelled, I'm going to have to integrate again. So the distance travelled is going to be the integral. Now this time I want to integrate from 0 to 20, so between those two, 4t minus 0.1t squared. And that's with respect to t. No constant needed there, remember. Okay, so if I integrate both of those, well, 4t becomes t squared times 4 divided by 2. Well, that's just 2t squared. The t here squared becomes t cubed, the power goes up, and at the same time we need to divide by 3 there in order to integrate correctly. So if I put in these two limits, the second limit is 0, so that's not going to give me anything. So I need to put in the upper limit, so that's 20. So it's going to be 2 lots of 20 squared, take away 0.1 over 3 times 20 cubed. So that's 2 lots of, well, 20 squared is 400, minus 0.1 over 3, and that's going to give me 8,000. And I stick that into my calculator, and I get 533.333 recurring. So the distance travelled, I'm going to round that to 3 significant figures, so 533 meters.